So what we're going to be presenting is a large-scale data sorting that we created. And I'm Fernanda Laureano, and this is...
I'm Edgar Rodriguez.
Okay, so first what we found to be the problem here was how to efficiently sort through a large-scale data set. So what we created was this sorting tool so that when people find themselves with this big amount of data that they want to go through and they want to easily access some values and they want to just say like, I want this sorted with this preferences that I have, and then I want to access this. And so what we created was something that it could help do this in an easier way. We found this to be a problem in many areas like data analysis, database management. So it has various application tools in the real world. And yeah, that was the problem. Then the solution. Okay, this looks very complicated, but it's easier. Well, the problems that we found were first how to read the file. Then the first thing that we do for reading the file is we used if string, that is part of the library functions of C++. With this, it just opens the file and it reads the file. Then the second thing that we needed was go through, sort everything, like all the rows and columns. Well, not sort, get everything into rows and columns. So what we did was first we used getLine, another library function, and this way it goes like it iterates through the whole data set, and it reads every line with this getLine function, and then we use iString stream, another function, and this way it kind of gets strings into input strings, and that way it reads them as like the comma separated values that are common in a CSV file, which is the input that we require for our program, and it reads them, and so it gets them into a cell. So it reads everything that's comma separated, and it gets them into cells. Then this whole thing gets into a vector that is the row vector, where every cell is put into this whole row, and then that gets into another vector which has all of the rows. So it's like a vector of vectors, all of the rows. I'm sorry, and it's like a vector of vectors. And so the inputs that the user inputs into the program, it's the data set that they want to sort, then the sorting preferences, and then we process it with the sorting algorithms that we choose, and then the data structure, which was the vector, which was the most optimal, and we will explain to you later why it is the most optimal one that we found. And then, well, the output is the data sorted into the way they want it. Also, the last thing that happens is they slice the results. They can choose how many amount of data they want to retrieve. Like, let's say I want just 5, this whole thing that I input, and then we show you the 5 rows and columns sorted in the way that you want. So the first thing it just asks through which column you want to sort it. You choose the column, and it sorts it, and then it will also ask. There's also another thing. It determines what type of data is in each column. So you choose a column, and then the algorithm will determine whether it's an integer, a string, or a date, and it will then, depending on which it is, it will ask you in which way you want to start it. For example, an integer can be from the smallest to the biggest, or the biggest to the smallest value. And so that's what it does. Then,
Well, this is our analysis and justification. So first, we're first going to we ask ourselves of which step our algorithm do. So first, we print the sort data involving iterating to a subject of the data printed itself. This is O log n, which is right here. So it's okay, but it can be better. So the most complex part of our project was the sorting phase because we search a more efficiently way to do it. So we found a solution called counting sort. So in the next slide, we say what is counting sort, and why we stick with the option of sort. So uh, complete store has a big O for a complete algorithm of O and N, which is kind of going like here. N is the number of data that we are, but that the user brings the algorithm, and K is like the limitations that the same algorithm or even the user tell the algorithm to read. So N is the number of elements, and K is the range of possible values. So here is what we stick with sort, even when counting sort has a better big O than sort. So first, with these crayons is how we explain counting sort. For example, you have a big list of crayons. Let's say 1,000. So you have 500 red crayon, 1,100 blue crayon, and some variety of colors and numbers. So content sort what do is that it groups each color. So you have the n numbers of red crayons, n numbers of blue crayons, and the other colors. So what it does is that it have all the groups of colors, and then inside of each group, it sorts inside. So sort is more versatile and suitable for a variety of data type. So in this algorithm, we have int, string, and date. So we thought that uh, sort was a better idea for this project. So in conclusion, well, context sort is more efficient in specific cases where where the data is like limitless. For example, colors or a small amount of numbers. So please go return to the flowchart. The flowchart.
Ah, sorry.
So, well, explaining in simpler words, the user start, load the CSV file, and then we ask him which type of data. He only have three options, whereas int, a string, and a date. So in base of what he said, uh, we also add invalid option with when he says, I don't know, like a special character, and the program will ask him again what he wants to do. So after that, uh, we make the process, and again, if it's not valid, it will return it. So uh, then we ask how many data types or how many elements he wants to return or become. For example, if we have a certain list of 1,000 and he only wants the first 50. So in base of what 50 values he has. So for example, a string he wants to order it to A to Z. So we sort the list and we bring the data that the user wants, and it is invalidated the return, and if it's not, it will end the algorithm.
Thank you. Well, we present the program. Yes, we will present all for the code.